insert operation, related to the normalization. When we see the normalization, focusing on three operations. First one known as a insert operation, another operation which is known as a update operation, and third operation which is nothing but delete operation. So related to that three operations, we have to perform the normalization. Okay, so when we say that we have to normalize data, that means we have to remove or minimize the dependency over there or redundancy over there. So how data is redundant, which is discussed earlier. Okay, so that means suppose there are a number of data with single records, then we have to update as well as delete for particular all those records. So that type of an redundancy is there. When we suppose insert a data, then we cannot assign null value over there. So that type of an dependency or redundancy related to the insert operations. Okay, so this type of an redundancy we have to minimize with the help of an this normalization methods. So here when we say normalization, then for database or the DBMS, the normalization consists of four types. Okay, or that consists of those considered as in four normal forms related to the RDBMS, Relational Database Management System. Okay, so one which is known as the first normal form 1NF, second normal form which is known as a 2NF, third normal form which is known as a 3NF, and last one BCNF, Boyce Code normal form. Okay, so it is an extended part of a 3NF. So there are four types of normalization methods that we can apply to minimize or to reduce redundancy from database when we apply three operations: insert, update, and delete. Okay, so when we say that we have to minimize or reduce the redundancy, then among from this four type we can apply any one. Okay, so we'll see how we can apply normalization methods related to the example. Okay, so first one, first NF or 1NF. First NF, which is also known as an 1NF normal form. Okay, so first NF or 1NF normal form, it is or it consists of atomic value. It consists of atomic value. What is the atomic value? One single record consists of a single value. That means suppose for example one student with different mobile numbers. Okay, one student with different mobile numbers in a TE computer database. Suppose there is a TE computer database. In that roll number, name and mobile number columns are among from that roll number 1 with two mobile numbers. That means one record which consists of multiple values. We can say that there is a multi-valued attribute over there. Okay, so what is the 1NF form? We have to minimize that things into the atomic values. That means each record consists of an only one value over there. Okay, so when we apply 1NF into that table, if there is a multi-valued attribute, okay, that time we can apply 1NF normal form. So what 1NF normal form state that 1NF normal form state that it consists of an atomic value. Okay, it consists of an atomic value, a table of an attribute which cannot hold multiple values. A table from an attribute which cannot hold multiple values over there. That means each attribute having an only single valued attributes are there. Okay, then and then we can say that it is in 1NF form. suppose if there are multi-valued attributes are there, then we have to convert it into the single valued attribute. Okay, that means that table we have to convert it into the single valued attribute. That form which is known as a 1NF form or one first normal form. So what is, I repeat, what is use of that 1NF form? In 1NF form, all records having a single valued attribute, that means atomic value records are there. For each record, on each attribute hold only single value, which will not hold multiple values over there. That time we have to convert a data set into the normal form. Then that type of an conversion which is known as an 1NF or first normal form. So we have to convert the data set in like that format, all records having a single valued attribute over there. That type of an information or that type of an conversion which is known as a 1NF or first normal form. Okay, remember always 1NF which leads to the single atomic value. Okay, so in this example, employee ID, employee name, employee phone number and employee state, among from that employee phone number having a multi-valued attribute, that we have to convert it into the single valued attribute. So when we convert that data set from multi-valued attribute to the atomic record or single valued attribute, then that conversion which is known as a decomposition into an NF. Normal database we have to normalize in, that means we have to decompose that database into the 1NF form. Okay, so here suppose employee ID, employee name, employee phone number and employee state, among from this employee phone number multi-valued attribute you have to convert it into the single value attribute. Okay, so that means the role employee ID 14 with two phone numbers. Employee ID 14 with two phone numbers. That means at the time of decompositions, you have to insert two records over there. One for one number, another for second phone number. That means employee ID 14, which will insert for two records. One for first phone number, another for second phone number. That type of an conversion which is known as a 1NF. That means this multi-valued attributes we are converted into the single valued attributes. So see here, decomposed table. In that employee phone number having and right now single valued attribute for each record. We are talking about the records. Okay, so for suppose first record 14, as in a previous table there are two entries over there. Okay, but now for decomposed table, in that each record having an only one value over there, having an only one value over there. Okay, so this type of an composition, which is known as a 1NF conversion. 1NF conversion. So only remember that when we apply 1NF to the data set, if that data set having a multi-valued attribute, that multi-valued attribute we have to convert in the format of single valued attribute with multiple rows. That means instead of employee ID 14, instead of one row, we are converting that one row into the two rows. Okay, so first one which is related to the 14 first number, another one which is related to the second number. So likewise we are converting or we are normalizing that data set in a 1NF form. Okay, so 1NF single valued attribute, multi-valued attribute records, you have to convert it into the single valued attribute. So this decomposition which is known as a 1NF form. Okay, so at the time of examination, the question which is asked related to this, explain normalization along with methods. So at that time, first of all, state that what is my normalization? It minimization of redundancy with respect to three operations: insert, update, and delete. After that, explain it with example. Okay, so 1NF, that means multi-valued attributes, so to convert it into the single valued attribute over there. So this type of an decompositions you have to state over there with example. So this is related to 1NF. Okay, so that means single valued, multi-valued attributes you have to convert it into the single valued attribute. The next type, second type of an normalization, which is known as a 2NF. Okay, 2NF stands for an second normal form. So when we say that we have to convert any data set into the 2NF, when we say that I have to convert some data set into the 2NF form, then it must be present in a 1NF form. Okay, so that means after applying 1NF, then and then you can convert that data set into the 2NF form. Okay, that means the prerequisite to convert the data set into the 2NF, first of all, that data set must be in a 1NF. Okay, so it is a prerequisite related to this. So, second normal form, in that second normal form, the relation must be in a 1NF. When we say that I have to convert that data set into the 2NF, that means that relation or that data set first of all must be present in a 1NF form. Okay, that means there is a no multi-valued attributes over there. So then we can convert that data set into the 2NF form. So first of all, in second normal form or in 2NF, relational must be in a 1NF. Relation must be in a 1NF. Then and then we can convert that data set into the 2NF form. Okay, so this is a prerequisite. Another one, in second normal form, on non-key attributes, all non-key attributes are fully functional dependent on primary key. All non-key attributes are fully functional dependent on primary. So when we say there is a primary key, then all other attributes other than the primary key, those are considered as a non-key attribute. Okay, so for example, P computer data set, roll number, name, and date of birth. Among from that, roll number is considered as a primary key. That means other than primary key, roll number, name, and date of birth, those columns are remaining, so those are considered as a non-key attribute. Okay, so that non-key attributes, those are fully dependent on a primary. For example, suppose I have to identify a Snehal student over there. Okay, so with the help of an only name Snehal, can I identify a particular student among from the 61? No, there is a possibility that in number of students having the same name Snehal. Okay, so instead of with the help of a name identification, I will call a roll number of that Snehal so that I can identify a particular one. Okay, so that means that attribute, name attribute, is fully dependent on a primary key. Okay, roll number. Another example, suppose I have only a particular date of birth of a particular student. Okay, so depends on the date of birth of a particular student. Can I identify that student? No. Okay, so to identify a particular student, I should know the name of that student as well as the roll number. Okay, that means that column also depends on the primary. Key attributes are fully functional dependent on a primary key. All non-key attributes, those are fully functional dependent on a primary key. Okay, an attribute that is not part of any candidate. Okay, the attribute which is not part of a, just a second, any part of an candidate which is not all called as a non-key attribute. That means other than the primary key attributes, those are considered as a non-key attributes over there. Okay, So we'll see one example related to this. Okay, in this, suppose there is a teacher database over there. Okay, in this there is a teacher ID, subject and teacher age is mentioned. Okay, in a teacher data set, teacher ID, subject and teacher age is mentioned over there. So at that time, if teacher ID is a primary key, then other two columns, those are considered as a non-key attribute. So with the of an only subject name, can we identify a particular teacher? No. Again, which depends on the teacher ID here. Depends on the age. Can we identify a particular teacher or with respect to the subject? No. Again, which depends on the teacher ID. So that means teacher ID is a here primary key, and subject and teacher age, those are considered as a non-primary key or non-key attribute. Okay. So this type of an data set is there, then first of all check whether it is in 1NF or not. So here suppose for teacher ID 25, the same teacher teaches two subjects, chemistry as well as biology. Okay, but which is already in a 1NF form. Suppose that data which is not present in a 1NF, if that data which present not in a 1NF, then you have to convert it into the 1NF form. Okay, so before converting to NF form, the data must converted into the 1NF. So here the teacher data set already converted into the 1NF. Okay, so 25, there are two entries, that means it is already converted into the 1NF form. Okay, so now for 2NF form, the teacher ID maps to the subject, teacher ID maps to the teacher age. Okay, so that means this data set, when we convert it into 2NF form, it converts it into the two tables. One table which relates to teacher ID and subject, and another table which relates to the teacher ID and teacher age. Okay, that means this two table decomposition, which is known as a 2NF form. This two table decomposition, which is known as a 2NF form. For example, suppose in this teacher database, okay, there are three entries or three columns over there: teacher ID, then subject, teacher age, and name of a teacher. Suppose then that in that case, three tables those are generated for 2NF. One for teacher ID with subject, one for teacher ID with age, and one for teacher ID with name. Okay, so in that case, three tables those are generated over there for 2NF form. Just prerequisite to this, first of all check whether those are already present in 1NF or not. If not, then you have to convert it into the 1NF. That means multi-valued attributes, those are converted into the single valued attribute, and after that convert it into the 2NF form. So yeah, while converting it into the 2NF form, the primary attributes, those are mapped with the non-key attributes. That means here teacher ID mapped with subject, it is a one table, and teacher ID is mapped with the teacher age, it is a another table. Depends on that, this type of and two values or these two tables, that form or that decomposition, which is known as a 2NF. Okay, so first 1NF form and then next one the 2NF form. Okay.